So our next speaker is Cecilia Aguerrebere. Cecilia got her PhD in signal and image processing from Telecom Paris Tech and in electrical engineering from Universidad de la República here in 2014. She was a postdoctoral researcher at the Electrical and Computer Engineering Department at Duke University in between 2014 and 2016. Her research is focused on signal processing applied to different domains like image processing, computational imaging, biomedical imaging, neuroscience, and more recently, she has been dedicated to data analysis for learning analytics. She has been a research, she has hold a researcher position at Fundación Ceibal here in Uruguay, working on educational data for data mining applications. Thanks, Cecilia.
Thank you, Pablo. Well, good afternoon, everyone. I want to first thank the organizers for the invitation. It's a great pleasure for me to be here today. And I have to say, before starting my presentation, that I had a very long trip from San Francisco, traveling alone with my 5-month baby girl. So if I start not making sense at any time of the presentation, clap your hands or do some kind of sign so I know that I have to reset one. So I'll switch to the educational domain now. And so when I was preparing the presentation, the first question that basically came to my mind was, how can data be used to improve education? But then I thought, well, is it obvious what I mean by educational data? So is it to you, do you all know that, what educational data is? Something comes to mind? Raise your hands or? Well, it's not so obvious then. So there are many sources where we can get educational data. So basically, it's academic information, enrollment, courses, grades, attendance, graduation or dropout, performance or results of tests. It can also be information provided by teachers, by observations such as student engagement, or clickstream data. So everything that the students do online in educational platforms, when they upload a resource, download a resource, make a comment in a discussion forum, so the text of the discussion forum, if they share images, so all the information related to learning platforms. Of course, you all heard of big data, and it's not an exception in education. So with big online learning platforms such as Coursera, edX, Khan Academy, a huge amount of student data has been collected in the past few years, and all that is being used to try to better understand the learning processes. And we have an excellent local example of big data in education. So let me introduce Plan Ceibal, which is, of course, much more than a producer of data. So Plan Ceibal, it's a government agency that was created in 2007. And it led the first universal implementation of the One Laptop Per Child program. So basically, all the students in primary public education in Uruguay have their own laptop or tablet provided by Plan Ceibal. That's 85% of the children in the country. Also, the students in the first year of secondary school have a device. And Plan Ceibal also provides internet connectivity to all public schools, and a wide range of online educational resources, such as an LMS, an adaptive math platform, and an online library. So from all those sources, we can collect a lot of educational data to try to better understand the learning process. So going back to our original question, I think that probably the first concept that comes to mind because of its impact, it's personalized learning. It's sometimes a controversial concept because it's not obvious what it means, so I try to somehow summarize it here. It's basically instruction in which the pace of learning and the instructional approach are optimized for the needs of each learner. Learning activities are driven by learners' interests and often self-initiated. So technology and data are fundamental tools for personalized learning, but they are not synonyms. So they are part of it. A clear example, well, what Jeff presented earlier, the app that it's helping the student learn how to read, that's a clear example of personalized learning. Another typical example are math platforms where the student go online and start practicing, let's say, fractions, so exercises to learn how to do calculations with fractions. So the platform will automatically detect that the student does not master a more basic skill, such as addition, and will redirect the student to easier exercises. So it's like having a personalized tutor. So these tools are very useful, but they will in no way substitute teachers. So something I've learned in these past few years doing research in this area is that every study concludes that the teacher role is critical, always. So basically the idea with these tools is to spare time to the teacher to do more complex stuff, so to teach the students higher level concepts and let them be guided by these tutors for simpler things. So here I wanted to list just another examples of other things, so that's not only personalized learning, that can also be tackled with educational data. So you can have an idea, modeling student engagement, self-regulated learning, using natural language processing to analyze the student's discourse or writing, data-driven feedback, performance monitoring, network analysis of the student interactions. But the list is really endless. Well, so now I'm going to present very briefly 2 projects that we've been working on at Plan Ceibal. So the first one is teacher feedback in online learning environments. This project was conducted in the context of a program created at Plan Ceibal to teach the students English, so as a second language. It targets secondary school students who are native Spanish speakers, who often struggle with English when they enter high school because they have very disparate English proficiency levels. So the idea of this program is to give the students material in English that it's made available to them through an online platform, and they can access it anytime they want. And so they read the material and have to post something in a discussion forum. That's like completing an exercise. So for instance, here, the topic of the material was Antarctica. So the student is asked to find one interesting fact about Antarctica and post it online. So the student said, the southernmost continent in the world, Antarctica, surrounds the South Pole. Then there is a remote teacher that will read the student post and will give him or her personalized feedback. Here the teacher said, great work. What do you think of the weather there? So the student replied, it is very cold. So this is the kind of interactions that we see in the context of this program. So we met with the educators in charge of this program, and they basically told us that for them it was somehow like a black box, the interactions that were happening there. They didn't have the ability to read them all, they couldn't really process them. So they wanted to get some insights on what was going on in these interactions. Actually, one of the first questions they asked us, they told us, we want to know which is the best feedback a teacher can give. And that was really broad. So we had many meetings with them and discussed a lot and could narrow down that idea to these 3 research questions. So the first one is, how complex should the teacher's feedback be so as to encourage the students to write more in the forum, so to participate more in the program? Then, should teachers' feedback complexity be congruent to that of their students? And the third one, how does teacher feedback affect the probability of engaging a student in a conversation? So of getting a student to keep replying in the same thread. So to answer these questions, we studied the relationship between the students' posting behavior, so the total comments they post, and their probability of response, and some characteristics of the teacher feedback. The complexity level of their comments, the polarity, so the tone, whether positive or negative of their comments, how specific the words they used were, how long did they take to reply, and whether they asked a question or not. I don't have time to enter into details of how we implemented these features. We got to this list, again, in several meetings and discussions with the educators in charge of the program. And all the details are in our publication in this year's International Conference on Educational Data Mining. You can check that there. So what did we find? Basically, we used both parametric bootstrapping and parametric models to study these questions, and we find consistent results with both approaches. We studied separately students with low and high English proficiency level because we thought the answer to these questions might be different depending on the student level. And we found that for both groups, students post more comments in the forums when the feedback they receive from the teachers has a complexity level that's close to theirs. So the answer by the teacher cannot be neither too simple nor too complex. And we met in a follow-up meeting with the teachers. We presented these results, and we asked them what did they think could be the cause of this. So basically, they said that one possibility is that students are more motivated when their teacher's language is accessible. So students are challenged by it, they learn from it, but they don't get frustrated. So for instance, if a teacher replies, great work, thanks, it's like not enough, it's not engaging. But if the teacher replies with a paragraph like that, they get frustrated. They cannot understand it, and they give up. So that's basically what could have happened. So it has to be somehow adapted to their level. And this is good not only because it's better for the student, but for the teachers, it takes much more time to write a long response that may not be useful in the end. So we found that some teachers oppose randomized controlled trials due to issues of fairness and practicability. And we find that observational analysis like this one can uncover some simple practical guidelines that may be helpful. So the next, second and last project I want to briefly introduce is we studied the effect of new device deployment on students' online activity. So as I said, Plan Ceibal implemented the One Laptop Per Child program in Uruguay. And we know these programs can be very useful, but to achieve meaningful learning gains, we need to take many other aspects into account, of course. So provide teachers with training, provide hardware and software support to ensure the devices remain usable, and device replacement. That's something that it's probably not obvious when we think about these plans, but the device that you give to a student in the first year of primary school, you cannot expect that device to be usable 7 years later. I mean, how often do you change your devices, right? And so that is a big part of the program because it takes a lot of money. So the research question here was, how are learners' interactions with online educational resources affected by receiving a new laptop or tablet computer? Does it change something? I mean, we give them the new device. Do they do more things online, or is it exactly the same? So we have two options to do causal inference here. And randomized controlled trial could be the first option, but it's often not possible. And here it clearly wasn't. So I want you to think, what if I tell you that we're going to split the audience? So those of you on the right are on the treatment group, and you will receive a new computer. Those of you on the left are on the control group, so you keep using your old ones. You probably wouldn't be that happy, right? Well, primary school students wouldn't be either. So we cannot really give some of them a new computer and not to others. So we're going to follow a quasi-experimental approach where we examine how learners who received computers as part of this program are affected by new device deployment in terms of their interactions with online educational content. So how do we do this? Basically, this quasi-experimental analysis is enabled by the way the laptops are delivered by Plan Ceibal. So there is a truck that goes to different schools, and basically almost all students in all the schools that are part of the program eventually receive the new device. So there is no selection bias as to whom is enrolled in the program. Also, the delivery dates are essentially random across schools. And all the students in the same grade, in the same school, almost all receive their device on the same date. As I said, these dates are essentially random across schools, and more importantly, they are independent of the classroom curriculum. They just depend on the logistics of the truck. So we have no selection bias, and delivery dates that are independent of the classroom curriculum. So this enables us to do this quasi-experimental analysis with the delayed treatment design. So we found that when students receive a new device, they interact more with the platform. They, with the learning management system, they post more in the forums, upload more files, check more resources, and they also engage more with the math platform. So they do more exercises. Which are possible explanations to this? Well, novelty is one of them. So they get a new device, they want to try it, they go online, they do more things. But it could also be availability, because their previous device could have been broken. So getting the new device actually enables them to start working again. This study was published in last year's EDM conference, so you can check the results there too. So I wanted to finish with two concepts that I think are very important. I somehow mentioned this throughout the presentation, but I think interdisciplinary work is really critical in this field. At least I've experienced that in the last few years working with teachers and educators, because we can get our data set, go to our desks, and 6 months later go back to them and present them some statistically meaningful results. Statistically significant, sorry, but will those be meaningful? So I think it's very important to work with them from the very beginning, defining the research questions to find what they really need or want to know, and then work with them throughout the whole project, getting their insights, which are extremely valuable to get to a high quality result. And the last thing, it's the importance of student and teacher privacy. In our case, it's absolutely critical. We're working with underage students. So, of course, this is absolutely critical to always take into account the privacy of the data and also the ethics of which research questions we can ask, how far we can go using this data. Thank you.
Thank you very much, Cecilia. We have time for 2 questions.
Hello, hello. So, first, thank you for the talk. I see a lot of resemblances with the Plan Conectar Igualdad in Argentina. So, I meant to ask, have you been able, or do you intend, or do you have a line of research into gathering this data and somehow transforming the curricula into a competency-based curricula? We tried that at Argentina, and it was kind of hard, so.
Yeah, thank you for your question. That's an excellent point. Actually, not really, the research I've conducted in Cebal Foundation is not that related to that, but Plan Cebal does have a big program that's called Red Global de Aprendizajes, or deep learning, actually. It's not the same deep learning here, but also in that sense. And basically the idea they're promoting, it's working in projects and all the evaluations focused on abilities, as you said. It's like they care mostly for creativity, critical thinking, collaboration, and 3 other C's that I don't recall right now, but it's exactly that. So yes, Plan Cebal does have a very, very big program that's exactly focused on that.
Okay, thank you.
If you're interested, I can send you more information later.
Oh, please, thank you.
One more question.
Thank you for the talk. Did you try to design an experiment to see whether it was novelty or availability that make the students use the devices, use the educational platforms more?
We started working on it, but we haven't really moved forward in that direction. We have it in the future work list. We are absolutely interested in that point, but we had some data quality issues that slowed down that project. But once that data is available, we're definitely going to look into that because it's really, really important. So yes, thank you.
Okay.
Thank you.
Thank you, Cecilia. Great talk.